Okay, everybody, first on the list today we have Objective 48, identify tangents, secants, and chords and the properties of tangents. So first I have the circle that I've neatly drawn for you, there's all these crazy lines in it and we're trying to figure out what all this is. So first we're looking at tangents. The tangent would be right up there, Ji, and I have it written right there, Ji. A secant would be HB. It goes all the way across and all the way through. It's a line, HB. And I have three chords. I have HB, it goes from there to there across the circle. I have EG, which goes from there to there across the circle, and AF, which obviously goes across the circle. The point of tangency, which is what pot stands for, not marijuana. I, right there, is the point of tangency. Diameter. Okay, so we're looking at all the different diameters here where it crosses the middle also. HB and AF. And we have a lot of different radiuses. We have CB, HC, AC, and CF. And that is Objective 48. Next on the list we have Objective 50. And Objective 50 deals with finding the area of sectors and segments. So first find the area of a sector, which would be CHJ, is what we're trying to find here. We know this angle right here is 131 degrees and that the radius is 12. So the equation to find the area of a sector is pi r squared times m over 360. So if we just plug those numbers in, you plug in the 12 and the 131, you pretty much end up with 52.4 pi for your area. You can also multiply that pi through if you want, but if you just leave it in terms of pi, it's easier. Now for the segment, it's a little bit different. That's what we're solving for, CHD here. Segment is pi r squared times m over 360 minus 1/2 base times height. So if we plug all these things in, but wait a second, what's our base times height? That's where we have to start dealing with our 30, 60, 90 triangles, people. Okay, so we have our 30, 60, 90 triangle right here. We know we get the 9 from right here, okay, and we have 4.5 because that would be half, and then we have to have half of this times the square root of 3. And then we just plug all that back through. You have 84.8 here, plug that in there, and you have 2025 times the square root of 3. Multiply all that through and you end up with 49.75 centimeters squared for your area of your segment. And that's Objective 50. Alright, our third objective we're covering today is Objective 54, which deals with finding the lengths of segments formed by lines that intersect circles. Alright, so let's get started here. First we're going to start over here. Now these chords in this circle right here intersect inside the circle. So this is how you deal with this. You're going to have to multiply the two numbers that make up the lengths of each line. So you have to multiply 14 times x and 7 times 10 and set them equal to each other, which I have laid out for you perfectly right here. So after you multiply all that through, you ended up getting x equals 5. Now you're not done yet. Now you have to find what each line's measure is. So you just have to add these numbers now. So 7 plus 10 would equal 17. That would be EF. And GH would be 19 because 14 plus 5. So next let's look over here at this circle. Now this one's a little bit different because the line extends out of the circle. Now don't freak out because I'm here. We're going to do this, okay? We have x and 8 and 9 and 7, okay? So what you're going to do here is you're going to add these two numbers. So you're going to add x plus 8 and then multiply it by the outside number. So x plus 8 times 8, and then you'll do 9 plus 7 times 7. So we have 8 plus x times 8 equals 16, which is 9 plus 7 times 7. Once you multiply all that through, you get x equals 48. After that, you have to obviously add up what each measure of the line is. So GE, you do X, which is 48, plus 8, which is 56. So that would be GE. And DE is 9 plus 7, which ends up being 16. The final circle here is a little bit different from both of them. It has an element of this because it extends outside the circle. So you're going to have to do 15 plus 5, which is 20, multiplied by 5, so 20 times 5 equals x squared. So you're going to have to square this and plug it into this equation. So we have 100 equals x squared. And if you do all the math out, you end up getting 10. And then when you add up these lines to get the measures, 15 plus 5 is 20, so ML equals 20. And KL, which is your x value, is just 10. And that's objective 54. Okay, finally, our fourth and final objective, thank goodness I don't have to do this anymore after this, is objective 55. Now, what we're doing in objective 55 is writing equations and graphing circles in the coordinate plane. So right here our problem says we have a center at 1, 2, and it passes through 1, 5. So the way you're going to have to go about this one is you're going to have to use the distance formula. And basically what this D is ending up going to represent is going to be your radius. So you're going to have to plug all these points into this equation, the square root of x2 minus x1 squared plus y2 minus y1 squared. So once you plug all these points in, you end up getting 3, which is the radius. Okay? So now you're going to have to use the center to plug into this equation, of the equation of a circle. So you get x minus 1 squared plus y minus 2 squared equals 9. That's your equation for this circle. Next, you have to graph the circle. So you obviously plot the center, which they already give you as 1, 2. So you go 1 up 2. So that's your center right there. Next, you have to use this radius that we found in the distance formula to find the rest of the points. So basically what we're just going to do, we're just going to go up 3, we're going to go to the left 3, we're going to go down 3, and we're going to go to the right 3. And I plotted all those points for you and drew that circle. Yeah, so that's how you do it. I hope you know geometry now.